recording about how my Floodplain project works. It's a project that streams data from one database to the other. There's a more explanation here. So let's get started. So example 1. It looks something like this. There is a Kotlin definition that extends Quarkus application because it's a command line application. It has a Quarkus main, so this will be the entry point. First, it defines a stream where the transformation is. I'm going to transform a Postgres database with film data, fake film data, with films joined with some actors and here and with some categories here. Doesn't really matter. Once it has this stream, when it's done, it will compile it to a Kafka Streams topology, and then it will run it. It looks something like this. So before I can do that, I first need to start my databases. I do a Docker compose. I'll show the Docker file. So there's MongoDB, there's Kafka, there's Zookeeper, there's Postgres, and there's a Kafka Connect. Docker compose up. So while this is charging up, I will switch to another tab, and here I will build my Quarkus build. Precious time ticking away. So now I can do java -jar build and then put the example thing here. I need to add something though. I need to tell it where Kafka is. So it's here, host and then 2 and connect. I also need to tell it is HTTP localhost 8083 is kind of standard connectors, and then the buffer time. I'll get to that later. 1000. And off it goes. So if we're gonna take a look at our destination database, we're gonna connect to MongoDB here, and now it has this database, and it contains films with actors joined. Not all of them are here yet, I think, and there are categories, right? So this is how that works. So see, now there are a little bit more. There were 3 before, now there are more. So it should be about done now. So now I can, for example, start changing the database to see how it actually streams. So here we have a film with ID 105 with 8 actors. So let's go to Postgres, and while this is running, I go here and I say delete from film actor where film ID is 105. Typo. It deleted 8, so that seems to add up. And now if I reload, the actors are gone. So while this is running, this will keep it in sync. It's eventually consistent, but if you don't make ridiculously big transformations, it should be in milliseconds. We are going to do pretty much the same code. I already compiled it here. Let's look at the Docker compose file, because now we see there is no Kafka, there's no Zookeeper, there's only Postgres and MongoDB. So let's bring it up. And I already compiled it, so let's run this thing. And you can see that it still runs even though there is no Kafka. So I'm now running the Kafka Streams implementation locally without the Kafka cluster, and Kafka Connect as well. It's a little bit slower, but it does make it a lot easier to run, especially for testing or smaller setups. It's much easier, and the result is the same deal, because it's not very entertaining visually. But here I'm doing the same thing, but I'm pushing it towards Elasticsearch. Here's the actual sync. So for the rest, it's exactly the same code. Elasticsearch can be really practical to make relational databases really indexable. I mean, if I want to search for a certain first name of an actor and a part of the description of the movie, really easy in Elasticsearch, really hard to do that generally in relational database. We are listening now to the payment table. This table of total payments from customers, and then we have a scan operator. This is like a scan or reduce or fold. It will make an aggregate over the entire table. This is the block that gets executed when you add something. This is when you remove something, and it just creates an account, joins it together, and sends it to Google Sheets. So let's see it in action. Again, I have a Docker Compose file. I have the Postgres, no Kafka, and I also added a small application that just keeps inserting some random data into the database to make it a bit more interesting to look at. So now I'm going to start our application. It's right here. It's going to run, and then once it's running, we can have a look at a browser. And there we see it processing all the changes until it is caught up. At around 60,000, it's caught up, and then it has processed all the data. But it will still remove a little bit because it's inserting random data, right? So it is slowly growing. But still, I can go to the command line and log into my database. And from there, I can, for example, jump everything from the table. And then you see that it tanks down again until it's close to 0, because it will recover because it's still inserting. But this way we can connect Postgres to, for example, something like Google Drive. And the nice thing is that there are a lot of no-code, low-code platforms like AppSheet that use Google Sheets as a source. So this way you can glue things together. Next, final one. WordPress. Here's a very simple one. I just listened to a simple table in MySQL, WP posts, and I put it also to stream it into a Google Sheet sync. So the Docker Compose file looks something like this: a completely vanilla WordPress with MySQL with change capture installed. Oh, that's running. So if I go here and I run my Quarkus application, I can switch to the example sheet, and here you see some of the data in there. If I go to a tab with the admin for WordPress, I can edit it. It says hello world, and I can change to hello Quarkus Hackathon, and I can update it, and then you see here that it immediately changed. So the point here is not so much that this is really difficult, but that as long as you can integrate with any application that has a database and you can figure out the data model, you can easily do this kind of integrations. And that was all I wanted to say, and see you around.